Hello, and welcome to this lecture. This lecture is entitled Building with AI Agents. And so we want to dive into this topic mostly from a practical and introductory type level. Um, some things I want to cover are some basic industry level concepts, as well as then applying those to a real Laravel application. So let's go ahead and walk through some of the information here that I have on some up and coming slides. What we want to do, like I said before, is lay the foundation, right? What is an LLM or large language model? What it is and what it can't do, right? And then how a model, for short, you might hear some folks say model, but that's just short for LLM, right? Large language model. How it becomes an agent, right? And then what are prompts, tools, and agent loop and memory, right? Those types of foundational pieces of information, we're going to have to understand what they mean and how they work. Secondly, we want to get into building, a basic agent in Laravel. So again, the foundational part, the LLM, the model, the prompts, that's industry. Those are industry terms, and you can create agents in any language on any platform. So for this particular example, we're going to be using Laravel and PHP and build a command that we can run and test our agent uh, in Laravel. So what is an LLM? What is it? What can it not do? Like I said, it's a large language model. It takes text in and then it'll predict the next chunk of text out, right, in its most basic form. And so what it can't do is it can't act on anything, right? It can describe sending an email, but it can't send one. It could remember calls and but it always starts from a blank slate, right? So it can't remember things. And then it has no access to, your database or other types of data structures in your application, right? All it can do is just take some text in and give you text out. So that is a limitation, but we have to be able to work around that limitation. And so notice on the right side, you might have a model which is given a prompt, for example, translate the word hello, and bonjour is something you might get back out. So that's great, that's a good start, but we need to be able to do more than that, like acting, remembering, and looking things up to make our model, our agent, much more powerful. So what is an agent? An agent is an LLM placed in a loop. All right, so given instructions, tools, and memory. Remember, a model, a large language model, cannot do the acting, the looping, the tools, the memory. The model can't do that alone. It just takes text in, gives you text back out. But to make this more intelligent, we want to have what's called an agent, which is going to allow us to try to reason about what to do next. Try to uh, plan for what's the next action to take. Try to the best of its ability, observe the results, and then repeat this until a particular task is complete, right? So, and then keep in mind, um, this can be done, agents can be created in any language. We're going to be using PHP, but they can be done in Python, TypeScript, or whatever. So just keep that in mind. So again, models basic with limitations, and agent given these extra looping and instructions, tools, and memory becomes more intelligent, working towards a goal. So just to kind of look at the anatomy of an agent, we have our model, which is our reasoning engine, right? That's text in, text out with some basic reasoning. But an agent also can have instructions. So who is it? What are the rules? What are the goals? You may have some tooling, so some extra functions you can call to act and look things up. And then memory. This is really, really important. We need to be able to have context. Remember, if we're inside of a loop, right, we're repeating and getting towards a goal, and we want to get better and better and better until we accomplish that goal. Well, we can't do that unless we have memory. We need to have context of the situation. So we'll take these items one at a time and work through them. So prompts and system instructions. System prompt, we want to identify this agent's identity, rules, and boundaries. So, for example, on the right, you'll see this agent, we can define what it is. You are a support agent for Acme. Be concise. Never promise refunds over $100. For example, if this is a tool that's managing products and balances and shopping carts, you can define that. System prompt can be as large and as detailed as you want. And so, um, depending on the type of system that you worked in, your system prompt will be very unique to what you're developing. User prompt is actually a real user interacting with this. So, for example, on the right side, you'll see, where's my order number 5821, right? So that's just something typical a user might prompt to give to an agent. And together they form the context the model reasons over. So you want to make sure a good system prompt covers four things. It has a role, has the type of tone you want it to interact with, the rules you want it to follow, and a goal. So rules are important because you don't want this agent to go rogue and start making up things and hallucinating, which is something you'll hear in the industry a lot is, oh, that agent is hallucinating. It's not even talking about or trying to help me anymore. It's off on some tangent. So we want to make sure rules are strict for your agent. And then you want to make sure it all comes down to an end goal, right? You want to make sure agent, its goal is to give you something that you need and want. So that's how those two, system prompt and a user prompt, will work together to build the context for this interaction. Tools and function calling. So tools, a function you may expose to a model um, to give you some extra power to your agent. For example, you may want to give it a tool to look up an order so that it knows it can get more information and detail for you, so it can better reason and give you the goal that you want. So all of these together is the putting together what we have is the agent loop. So you have number one, the reason, number two, being able to act, and number three, observing. And so given the goal and context, decide the next step, because remember, you're in a loop. Acting, you want to be able to call a tool and produce the final answer, or at least get closer to the answer. Maybe you'll get it after so many loop attempts. And then observe, right? Read the result, add to the context, loop again. The goal is to get closer and closer to the goal. So a loop in action here is you might have a user prompt saying, where's my order? It's late. The reason, I need the order status, and then you'll call, the agent will then call a tool. And the acting part of it is do a lookup on this order. Observation. Well, the answer returned back is the status is shipped with an ETA. And then the reason is I have enough to answer. No more tools needed. And then now you can act. Good news. It shipped and arrives Friday via UPS. So this is the agent in action in the agent loop given their user prompt. So it's kind of cool, to see it, how it works, but over time, these agents can do a lot for you, given enough, context, rules, and goal to do that for you. So a little bit more about memory and context. We have context, or what's called the context window. And this is everything the model can see in one call. So I would kind of use an example. If you're coding some sort of script and you run the script, well, the script is going to start and it's going to stop. And within that time frame, that's the context of a running script. And that would be more an example of like a context window. It's what it can see right now. Okay. Short-term memory is the current conversation. So it does carry prior turns back in so that the agent stays coherent within a session. And so um, this is again working through each iteration at a time, one at a time. Long-term memory is facts saved across sessions. So you have multiple sessions, multiple user prompts, um, multiple agent loops. So, but over the long term, you have full context of the whole situation. So, like I said down below, memory isn't magic. It's just deciding what text to put back in the context next time. And so that's really, really important when you're managing your memory, managing data, managing context. It's something you'll hear a lot when you're dealing with agents. How are you going to manage the context? So, part two is building an agent in Laravel. So we want to be able to take some of these ideas, right, an agent loop, and all the steps that go into an agent loop, and everything there to build something in PHP and Laravel specifically. So again, why use a framework at all? Well, a framework's going to give us, an API. It's going to give us the tools to run an agent loop and allow us to do testing to make sure our output is correct. So again, same job, other ecosystems, Python, JavaScript, OpenAI, Laravel AI. There's, all this terminology that we've been using. That's industry terminology that can be used in any language and any platform. So kind of just keep that in mind as we work through this. So the Laravel provides an SDK. On any Laravel application, you can just compose or require Laravel/AI, and that will bring the AI SDK into your Laravel application, and it gives you all the tools you need to manage agents, tools, memory, output, and testing. So this is huge. This is awesome stuff. Um, we're not going to have enough time to get into multimodal, but the Laravel AI SDK gives you the ability to interact with text, images, audio, transcripts, embeddings, lots of really cool things. Built-in tools, web search, web fetch, file search, um, being able to retrieve information and use it intelligently within our application. So good stuff. That's why we're using a framework. It's going to give us all these things built in. So what are we going to build? We're just going to build a support agent that drafts replies to incoming tickets. So for example, a customer emails, "Where's my order?" The agent looks it up, checks our policy, writes a grounded reply, escalating anything it shouldn't answer alone. So again, keep in mind, what's the goal? What's the end goal here? Why are people using agents nowadays? Well, a lot of this used to be answered by a human, right? Or some way a human would have to reply to all these emails, and that would just take too much time. It's not too scalable. But agents are there, ready, willing, and able to respond to these and give intelligent results. So we want to build up now our instructions, tools, and memory for this example. So here's an agent and its instructions. So in Laravel, we use the Laravel AI agent library, and we can create a class, name it whatever we want. In this particular case, it's support agent. It's going to extend or inherit from agent, and it's going to have a public function called instructions. And notice right away, what's this instruction? Well, it's a system prompt. Remember, a system prompt is we need to define the role and the rules and the goal for for an agent. So that's what this system prompt is. You're an Acme support agent. be warm and concise, right? We're setting that tone. Always look up the order before answering. Escalate any refund over $100. So this is, we're setting these guidelines, this system prompt for this agent, so it knows how to behave. We don't want it to go rogue. We don't want it to hallucinate. So the better our prompt is, the less likely those other things are going to happen. And so here's a tool. Remember, a tool is just an external piece of functionality that the agent can use. So in this particular case, it's going to want to be able to look up an order. So we can just give it an order model, find or fail, do a lookup and give information. So that's cool. We also have a refund policy tool function that, if an amount is over 800, do some other things, escalate or auto approve depending on what's going on there. So these are just tools that are going to help out the agent when it needs it. We want to be able to add memory. And again, the Laravel AI SDK gives us the ability to do that, where we take messages from one loop and add context to the next loop. And so we can use this with memory function to have some short-term context. And then we also can use our database as long-term context. So this is too cool, right? So we know how to persist or create records in our database. So we know how to use that create command. So again, adding memory, that's important. And then we can run the agent. So we have a reason, we can act. We have another reason, we can act. And then the reply ultimately is, hi, your order 5821 shipped and arrives Friday via UPS. So we're able to give an intelligent response based off the agent's tone, rules, and goal is to give you this information. So that's cool. And again, this is endless scaling, right? These can scale much better than humans can. And so that's kind of the ultimate goal of why we use agents. Finally, kind of another just an added bonus here is Laravel gives us a command to make it runnable if we want to test this out. So we can use artisan commands. We've been using artisan commands a lot already. So, PHP artisan, run a migration, PHP artisan tinker, there's a lot of built-in commands that are in Laravel. But we could actually create our own artisan commands. And so we can, set it up. For example, this one's called reply to ticket, which extends or inherits from the command that's built into Laravel. We have to define a public function handle. And then, now we can kind of go to town. We can look up a ticket, and we can now instantiate a support agent, give it the ticket's messages, respond to its last message, get a reply, and then return that reply out with the final result. So the agent does its work, and then after it resolves it and has a final result, it can do a reply. So look at that. Just with a few commands, we are now exercising our agent. So that's really, really awesome. So now if we want to run it from the terminal, notice PHP artisan, it's how we start all commands, whether they're built in or we're using our own. So PHP artisan support reply 5821. And if you go back up above the class reply to ticket, it says signature, signature support : reply. That's actually, you define what your artisan command is named. And so that's why on the next page, on the next screen, it says PHP artisan support : reply. And so then we're passing in a ticket number, and then we get a message drafting reply for ticket, and then the tool's doing its work, and then finally the reply draft comes back, and we can see what the answer is. So that would be a pretty typical thing if we're going to just test this out from a command. So this is your fastest test loop. We edit, we can rerun our ticket, our support ticket agent, and we can read the replies, and we can just do this over and over just to make sure things work. So really, really fast test loop. So why is this a good place to start? Well, it's number one, it just makes sure your agent is even working, make sure it's working correctly. Once it's working correctly, then you can incorporate it into your Laravel application, right? You could have a controller action, so someone can actually submit a form, and that form data comes into your controller action. You can run your agent, and then the agent's going to get a reply, and then you can send that back out to the web page so users can see the reply to a particular request, right? But what we're doing now in this particular example is creating an agent and running it in an artisan command first to make sure it works. So again, you can see here, I was mentioning before, you can run this artisan command, and then when you feel good about it, heck, once you're in production, you can run, in this particular example, it's called a webhook or a queue job. You can run your agents in the background to eventually give replies and drafts to humans. So all sorts of ways. I mentioned putting your support agent inside a controller action. Like there's lots of places this support agent could go. But what we're doing first is building and testing within an artisan command to get quick testing feedback. So that's pretty cool. So what did we build, right? We have instructions, we have tools, we have memory, and an artisan command, all so we can, test this support agent very quickly. So taking the concepts and mapping them over to Laravel, on the left side is a universal concept. Like I said before, these are concepts that are industry standard. And these are the same concepts in terminology you would use whether you were in TypeScript or Python or C# or Kotlin. These are the universal concepts are the ones you'd want to use if you switch languages, right? If you go to a different platform. But for what we're doing now, you take these universal concepts and understand what they mean. So in review, right, system prompt is the agent's identity and rules. Tools and function calls, right, those are functions that can help aid the agent do its job. The agent loop is our reason, act, observe loop that we keep refining and refining until we finally get to the answer. Memory is what we want to be able to preserve context while we're in this agent loop. We don't want a fresh blank slate every time, right? We want to make sure we continue to build context as we move forward. And then finally, we want to be able to invoke and test this behavior. And so in the far right, you see the Laravel AI SDK items that are matching in the code what we're using to make those things work. So this is kind of a cool table to see, universal concepts, what they mean, and then how we actually apply that in Laravel. So again, these patterns are universal. I've kind of been hitting on that a lot because you may not use Laravel in the industry. You may have a choice and you can choose to use Laravel. If that's the case, then awesome. But if not, more than likely, you'll come into a JavaScript framework or you'll get into a Python framework. So just make sure that you're comfortable with the universal concepts. So some things to walk away from this presentation with is, again, models or LLMs. Their very simple job is to predict text, but we can wrap that predictive text, that predictive model in an agent and give it instructions, tools, and memory to make it do more work for us. The tools let the model act. Your code always runs the real work, all right? So number 3, the acting and observed loop is the engine of every agent, right? That loop is just gonna happen over and over until you finally get to your goal. We use an artisan command as a quick turnaround, a way to test our agent so that ultimately we can use them in controllers, background jobs, anywhere we need that intelligent result, we can use it somewhere else. And yeah, we're using frameworks like Laravel AI to implement these ideas so that we can do some cool things in a real working application. So definitely keep learning. You definitely want to look up laravel.com/AI. There's laravel.com /docs /AI dash SDK for full docs. Lots of cool things out there. This presentation definitely just scratching the surface, but it's a good place to start. You have to start somewhere. And so, yeah, I thought we covered a lot of good ground, a lot of good basics, but also was able to walk through a real application or an example agent with it. So, all right, well, that's it for now. Definitely be thinking of future thinking questions. You know, start jumping into PHP, Laravel, trying some of these things out. I'm sure you'll run into something, but that's how you learn. So, all right, well, have a good one. Until next time, we'll see you. Bye.